Okay. All right, so last time we briefly talked about why we want to learn engineering materials in general. So let's put some key points down about why study engineering materials. I think one thing we talked about last time is it's everywhere. It's around us, right? Everything you can touch, it's a material. It's almost everywhere. And oops, what's going on here? Then no matter what industry you're in, engineering industry, I mean, you need materials. And another reason we want to learn engineering materials is, as an engineer in the future, you're gonna run into a time that you need to pick the best materials for your product, right? You're gonna make a decision to pick the best materials. So when you select materials for your engineering design, there are a few key points you need to consider. One is, what's the trade-off between properties? Especially some of the mechanical properties we're going to touch today. If you pick a material that has this property very good, but may lack other properties. So you need to keep a balance between those. Then we want to consider the criteria of the materials during the service or degradation. The deterioration of a material property during service. That give you more examples. That could be reduced strength, deformation, or corrosions. For civil engineers, those could be very important. Oops. There are more examples other than reduced strength, deformation, and corrosion. You can easily find this example in just the cars you're daily driving, right? So we have pretty heavy snow here. The corrosion, it's a problem over time for your car. So you, as an engineer in the future, you need to pick the right materials to kind of balance out all these factors to make sure it's a good product. And what other things we need to consider when you design engineer product? It's consider what's the cost of the materials, the economics, which is cost. Since you want to do business, all the engineer companies are business. They want to earn money. Then we also want to be responsible for our environment, our Earth. So think about what are the environmental impact. Okay, so those are the things we touched during Monday, why we need to learn engineering materials. Now, of course, there are more things you need to consider, put there, but that's kind of out of scope of this class. And next, we want to talk about what is materials, what type of materials we're gonna learn in this class. Since we've been talking about materials all the time. And so in this class, we are going to learn solid materials. There are other materials, but we're gonna only learn solid. Something is solid. So for solid materials, there are three main categories we're gonna touch in this class. That's how we classify or categorize different materials. We're gonna use these three categories to sort all different types. We have thousands of materials. We're gonna use this to sort all of them. So we're gonna have, the first type is metals. The second type of materials, it's ceramic. And can you guess what's the other one? Where we have metals, ceramics, plastics. Yeah, what you're sitting on, where's your hands and arms are sitting on. Desk, even the carpet, some of the carpets are made from, we use polymers instead of plastics in this class. A plastic, it's a type of polymers. So polymers. Yeah, those are the main materials engineer will use. And that's the three categories of materials in for this class. If you just look around, most of the things around you are made from those three categories. Let's take your car as an example. The frame, the body of your car is made from metals, right? Of course. And what other parts in your car are made from polymers? What? Tires? What other things? Seat belt, the dashboard, the lens. It used to be glass, but now it's all plastics. And what are the ceramics you can find in your car? What? Say that again. Sorry. The brakes, the brake pads, yes. And what other things are made from ceramic? Can you guess? What is the material of your windshield glass? Glass is part of the ceramic family. So the ceramics we're talking about here is not the traditional, what's that word? Porcelain or clay. We're talking about more big general family of ceramics. And what other ceramics you can find in your car? If you grew up in a rich family, you have, by any chance you have a Tesla, the electric motor inside, I think those are AC motors. But if there's a DC motor in your car, the magnets are ceramics materials, consider ceramics. And if you like me, you like to do some car works by yourself, if you have changed your spark plugs, the white stuff on the spark plugs, those are ceramics too. So there are actually more than, I think I read a news is 200 hundreds of different materials just inside of your car. Right. So the way how we get these 3 different categories, it's based on their chemical makeup and atomic structure. And atomic structure. We're going to talk about that later in chapter 2 and chapter 3. Look at what are the chemical makeup for metals, for ceramics, and what are the crystal structure, which is atomic structure for metals and ceramics. And hope if we have time, we can touch polymers. All right, besides, I have a question for you. Now, you mentioned we have 3 categories of metals, ceramics, and polymers. Besides those, do we have any other materials? Right. Then think back in imagine back in 2,000 years ago, what materials people are using. Stone, rocks, wood, organic bamboos. They're nature materials, and they're made by nature. We just take them, but that's out of scope of this class. And if we're talking about more like man-made materials besides the nature materials, we have another category which is called composite materials. Can you think of anything that is maybe belong to composite material family? Fiberglass. Yes, that's a great example. Anything else? Can you think of any where like fiberglass is applied? Where can some cars, boats? Yeah, a lot of boats use fiberglass. Aircraft. Besides fiberglass, what other things are considered composite material? Have you heard carbon fibers? Pretty similar idea with glass fibers. They're composite materials too. And even the plywood for construction, they're composite materials. So composite materials, it's a material that is has a combination of 2 or more different materials. Okay. Do we have any other different materials other than metal, ceramic, polymer, composite? Can you think about anything else? Just guess. You can give a wild guess. What? Clothing. I'm wondering how. I think some of the clothing are belong to polymers. I think they use polyethylene for some of the clothing, right? The jacket and stuff, jumpsuit. And some of the clothing are made from nature materials. I think everyone should have a smartphone, have a computer. Is there anything special inside of your computer and smartphone to make it work? Semiconductors. Those are considered advanced materials. And since we're in this area, keep in mind how the semiconductors change our culture, change our society. It's a revolution, materials. So next is advanced materials. That includes what we mentioned, semiconductors. And other than that, we have biomaterials. Any of you are bioengineer here? Yeah, we won't touch so much on biomaterials, but there's a big category. It can be a course itself talking about biomaterials. It's a material that's compatible with your body and has other properties. And there are other types of materials called smart materials. It will change its property, depends on the environment. And also we have another type of materials, non-engineered material. That could include nature materials. Oops. Okay, so now we have a general idea of what type of materials we have. And of course, there are more than thousands of materials in this world, and we are not able to touch every single one of them. And in this class, we only focus on these three: metals, ceramics. I'm going to touch a little bit on polymers. If we have time, maybe composite. That's it. And if you like materials, there's a major setup. It's called material science. They study different type of materials. Like I mentioned, for our course project, since we have so many different materials in class, we are not able to cover every single one of them. That's why I ask you guys to be an expert just for that one material picked for your final course project. So at least by the end of the semester, you will be an expert just for that material. Something you can talk about to show off in front of your family, hopefully. Okay. So next, we're going to jump to chapter 6 of our book. This is just some general intro, chapter 1. Next, we're going to talk about the mechanical properties of materials. The mechanical properties, since majority of you are mechanical engineering, civil engineering, bioengineering, the mechanical property perspective is more important to us. But before I show you any details, write anything more, just want to show you a video of the most important mechanical engineering test, which is called tensile test, or sometimes called tension test. And we're going to watch a video together to learn what is this test and how the test is being done and what result you can get from that test. And after the video, we're going to talk about the most important diagram for at least mechanical engineering, bioengineering, and civil engineers, which is called stress strain diagram. Every solid material would have a diagram like that to show you very important mechanical properties. So we're going to learn about that in detail today if we have enough time.